All right, hello, hi everybody. I'm really happy to be here talking today at this great event. So thank you very much, Erica and June and team. I'm going to be discussing a little bit of going back to the purposes of crypto and how we can use them to build very fundamental new systems for the world. And so it's going to be a bit of talking about crypto, talking about AI, talking about how we build technology and so forth. So without further ado, let me get started on that. I'd like to just set the stage for people who are listening because I'm going to kind of jump through a couple of different topics and it will all tie together at the very end. One of the first ones that I like to go back to is just talking about crypto settlement and decentralized trust. It's an important foundation because as we're talking about new Web3 technologies and AI, we have to get down to the core of like, what are we actually getting out of crypto that's net new? I think it's very easy to kind of, look at certain ways that we manage data and manage chains, but there's the underlying, what does this mean in terms of how we coordinate our efforts? Then the second part is going to be about Web3. And specifically this concept of verifiability in Web3, what it is, how we actually run technology that way. It was a great talk just before this on World and World ID. That's a terrific example of doing something that's verifiable that wasn't possible before. Then I'm going to extrapolate over to the AI space. We all know AI is really going to transform all of technology, how we work, how we live. And there's a little bit of, I would say, a scarcity of trust around AI. So looking at how crypto settlement and decentralized trust is going to help that. And then for all of us that are building technology, I'm going to relate this over to what does open source, open technology mean in this age of doing verifiable decentralized trust and the cloud. And then I always like to actually end on the net takeaways. So what is the value that we're going to have as people who are building technology, companies that are basically creating value in the new economy, and finally why all of us as consumers are going to win. So, okay, starting off from the very beginning, decentralized trust. Decentralized trust, the concept is that it enables something called crypto settlement. Crypto settlement has three aspects to it. The first aspect is financial settlement. This is the OG use case for crypto. Bitcoin allowing you to hold money that is not, trusted from a government, as well as transferred around, and that got expanded dramatically by Ethereum, adding in all sorts of decentralized finance primitives that we all know and love. Ethereum added not just the DeFi, but we've seen a lot of expansion out into what I call technology settlement. So how do we actually know that we're doing computation correctly, that data is being stored, that the bandwidth and availability of data is there, and going now into doing AI computations correctly and having the right provenance on data. So all of these I refer to as tech settlement. And the third one, which I think a lot of us kind of take for granted at this point, just show of hands in the audience. So everybody raise your hand for a sec for me, please. And then everybody who was in 2018 or lower in crypto, 2018 or earlier in years, can you keep your hand up? Oh, good. Okay, about 2/3 of the people who had their hand up remained keeping it up there. So we have people that I would say are like multi-cycle. So if you've been in, I would say before 2018, there was actually a lot of discussion about social settlement. So most of us know social settlement as layer one forking. It's to some degree a less known fact at this point, but maybe it's a little surprising to some of you that ETH, the ETH token, is not actually the original token for Ethereum. There is a token originally for Ethereum which is still being propagated on a proof of work chain, and it's called ETC. And it's been renamed to ETH Classic, but in fact, actually, ETC was the original token launched for Ethereum. And all of us decided around the time, well, those of us who were around 2016, that Ethereum had suffered a hack that had stolen 25% of all the ETH in the world at the time, which was truly devastating. And so socially, people decided that forget the mathematical rules of consensus and proof of work and everything. Vitalik sanctioned this, and the chain was just forked. And over time, it took about a year, but eventually everybody using Ethereum decided that ETH, this forked chain, was the valid ETH chain. And so I want you to think about that. For all of the immutability and everything that we have in crypto, social settlement and people deciding that this is correct or this is not correct, the human aspect actually overrides the math in cases where we decide it. So it's sort of saying that like the validity of a chain, the legitimacy of it, is created by human belief, not purely by math, as sometimes you think when you look at crypto. So social settlement, I call sort of the bedrock foundation of all of crypto. Without it, tech settlement and financial settlement really is not that different from Web2. You know, we do have financial settlement and tech settlement. Most of us are running software on Amazon Web Services or Azure or Google Cloud. And so the tech settlement is believing they're running correctly. We use standard banks, we use stockbrokers, you know, whatever we use. They do financial settlement. Why are they not crypto, and why is crypto different? And it's because of this decentralized trust at the social settlement layer. And for the purpose of this talk and for EigenLayer, the important point is that there's a couple of different types of social settlement. Of course, on-chain, we have DAOs. And so those are very helpful. Those are kind of like running corporations. Off-chain, we have this very, very powerful construct of layer one forking that allows you to actually decide which chain is valid, like the ETH versus ETC or the Bitcoin versus Bitcoin Cash type disputes that happen. And EigenLayer has created a completely new crypto economic primitive, which is called intersubjective token forking. And this is an important new primitive because we've decided as, across a community like Ethereum, that forking the L1 chain again and going from ETH to some other token name would be too disruptive. So EigenLayer adds the ability with the Eigen token that you can actually do an off-chain decision that forks the value of the Eigen token itself and slashes people who violated conditions that off-chain were considered to be unacceptable. And so that actually adds something to the off-chain forking that did not exist before. And you'll see that come up a few times in the talk here. And of course, these are the categories that the assets Web3, and I do really label social settlement as like a very significant thing. So I refer to it as the ultimate backstop, because without that ultimate backstop, somebody could just decide to do what they want on a chain and you'd have to go along. But social settlement allows you to just say, hey, I don't actually think that's right. I want something else. So in the context of how much does this matter, humanity has had some coordination engines, like gold, silver is the OG one from, at this point, over 5,000 years ago. Paper money, double entry accounting, these were very significant improvements. I'm always interested if people have other ones they think I should be mentioning, but these are the main ones that I think have been really significant ones. More recently, we had people invent common stock. The United States was the first place that a constitution was invented, going beyond feudal and monarchy systems. And this may be a little bit surprising, but I actually put crypto over 200 years of a gap as the next major coordination improvement that we've had for humanity. This is not a huge list. I have 6 things listed on this page over 5,000 years. So crypto is no small thing. So I just want us to think about that. This last one, Web3, it's a bit of a corollary of crypto, but this is where crypto, I think, is going to show its most value, which is using crypto, which started out as verifiable money. We can actually transfer that over into what we desperately need, which is we need verifiable AI, we need verifiable apps. There is a tremendous crisis of trust in technology right now. We see it all of the time when we use technology as well as when we see how it's being manifest. So just kind of wrapping this section up here, the secret that we believe here is that crypto is the greatest upgrade that we've seen in coordination for over 200 years, and it belongs in that family of 6. This is maybe a little bit of a stronger statement that people haven't heard before because everybody focuses on POW or proof of stake and all of these different mechanisms. But the core real net new thing in crypto is decentralized trust. And the reason why I say that is because if you take a Web2 application and you sprinkle, the tasty spice of decentralized trust to it, then it becomes a Web3 application. And if you take a Web3 blockchain or you take a Web3 application and you have it sort of pretend to be blockchain, but it doesn't really have decentralized trust, you're trusting some parties and they can kind of, move the community around the way that they wish, then the decentralized trust is gone, even though the technology looks like it's blockchain, and we're back to it being Web2. So the reason that's important to say is that decentralized trust is something that does not necessarily require a particular technology instance. It's something that requires how do we actually adjudicate the validity of a system. And I'll come back to that when I'm talking about AI. So, but first I want to just talk about verifiable Web3 in general. So in this section, I'm going to go through a couple of things that kind of show us what does the technology stack look like for decentralized trust in Web3 versus Web2. For blockchains themselves, 2 phases that we've gone through. We started off with Bitcoin, which was a completely monolithic application. So everything from the application, which was holding and transferring Bitcoin money, was the application, the execution of the scripts, and then the consensus and security of proof of work, and the the sort of economic stake that miners were putting in on building the proof of work longest fork choice rule. All of that was one piece of software, one application. Ethereum's big insight and value was that it realized the application, the smart contract layer, could be generalized. And so the ethereal virtual machine allowed us to introduce a first level of modularization there. The roll-up era for Ethereum has been a really big upgrade because now the execution layers became generalized. You could have Optimism, Arbitrum, ZK Sync. We have a good partnership with them. And the number of apps increased quite a bit. In fact, you could even call the roll-ups app chains in some cases. And so that was the roll-up area. And with EigenLayer, I think the key innovation that we've created is this idea that security, which has always been wrapped up inside of the consensus protocol, you could actually pull that out and make that a modular layer of its own. So you could take the tokens that normally are in proof of stake, you can put them into an asset pool, ETH, ERC20s. You could bring them onto a restaking construct, and then that restaking could be bonded to the security of entirely new consensus protocols. And so that's why now we see the shared security is separate. That's what restaking means. And consensus is now able to be added uniquely to services. And so, we call them AVSs, autonomously verifiable services. Each one of those can have any kind of protocol that it wants, and it can utilize tokens that it didn't create in its protocol, as if it was, Ethereum or Bitcoin, some kind of modular chain having that security bonded directly inside of it. So what does this mean for actually building tech beyond blockchain? And so I like to show, I think most of us, we kind of use this stack, but it's just helpful to see it again, going all the way from the infrastructure layers at the bottom through runtimes and middleware and applications. This is sort of the decomposition, the basic one for how software is built. And originally, this was all built on site, but over time, over the past about 20 years, we found that it's much more effective to do this in a cloud construct. And so, the original cloud was Amazon, and they started off with just the infrastructure, the IaaS layer, virtualization, server storage, networking, so things that were very close to actual printed circuit boards and chips. Then over time, the open source that people were building on top, they realized they didn't want to build everything from the operating system up to the application as part of their app. It just wasn't worth it for them to do that. They could build things faster if they utilized software services that were wrapped up in the platform as a service, PaaS, as well as the software as a service layers. And so software development became much faster, and we had more generalization. And in Web3, infrastructure as a service has been kind of renamed to DPIN, which is decentralized physical infrastructure. And platform as a service stays the same name, middleware, and software as a service, end user facing. And you know, the important point on why I show this here is, like, when we're talking about Web3, I don't actually think, like, there are people who look at Web2 and they say, oh, well, if you're going to run things in blockchain, everything has to become a chain. We have to take application after application and turn them into app chains. While that's possible to do, it's really hard to get software developers to change their stack. I mean, like, definitely we have tens of thousands of software developers that have done that. But for the millions of people who are building in Web2 right now, what they ideally want is they want a Web3 that looks essentially identical to how they build right now. And so the question for us is, you know, can we build decentralized trust into this Web2 stack without requiring everyone to figure out how to have tokens and, you know, the security and the special kind of blockchain services in their system? Do they have to really redo what they do on the software side? And so EigenLayer, you know, I'm going to talk about how we kind of view this, that there's two sort of verifiabilities. I talked about it before. The on-chain verifiability, which was things like, you know, portions of the tech settlement, DAOs, and money settlement. All of those are verifiable using existing tokens in Ethereum. So ETH itself is a token, as well as the protocol tokens, the ERC20s, that are anchored on the Ethereum chain. And then there's this other aspect, which is what I was saying before, the off-chain verifiability, so the intersubjective token. And that gives us a couple of important things. We can actually attest to things that are not provable on-chain. So, you know, if you look at a Poly market or an Oracle system, there's really no mathematical proof of what is the correct price of Bitcoin. It is something that you observe in the real world. If you are doing some kind of application that needs to bring in the weather in a region of the world or a state because you're doing some kind of estimates on, you know, commodity futures or what have you, again, you have to bring data in, but you can't prove it. So, you know, having crypto economic security is more about people losing funds for putting in false information. And of course, all of us can look and say, hey, if an Oracle is telling us that BTC right now is at $5, we know it's wrong, but we can't prove it. But intersubjective, which stands for shared belief, means we can all go on chain if we have the ability and say, that is incorrect, that person is lying, and they can get slashed. And so EigenLayer delivers a protocol where instead of during an L1 fork where it could take a year for people to decide what's the valid chain, in about a week or two, the adjudication of that completely finishes. And so you have definitively, it could be $1 million penalty, or depending on what people stake, it could be a $10 billion penalty. So you can size the stake to the kind of damage that you can have. 10 billion sounds like a lot, but right now, if you were able to actually fake out an Oracle on Ethereum and, you know, essentially get Bitcoin to a price like that, the amount of funds that you could steal from people on decentralized exchanges and other things is astronomical. So it's a very kind of scary world that, you know, we live in if we don't explicitly think about the security levels of our systems. Okay, so EigenLayer has this concept we've talked about a lot of AVSs. I think there's a few terms that EigenLayer has like brought to the industry. One of them is intersubjective. I do not think any of us heard this word. I certainly did not until EigenLayer decided to make us all hear it. It's kind of funny. It's like a very meaty, large word, but from a marketing term standpoint, it's kind of nice because there's no other interpretation of intersubjective. We definitely own that term. The other one is these AVSs. They originally had a slightly different definition to them, but over time we realized the plain English version of what they do is they are autonomous. And autonomous meaning that because the staking is permissionless, that allows anybody who has hardware, anybody who has a software stack to be able to run AVS software. And similar to being able to run like an Ethereum chain or a Bitcoin chain, that makes it permissionless. Once it's permissionless and there's a monetary incentive to do something, that essentially makes it autonomous or unstoppable because humans are motivated by incentives, and so someone is going to run a service that has that characteristic to it. And then the second one is that they're verifiable. And it's great when companies tell you they're going to do something. I like it a lot more when I know someone's going to lose money if they don't do what they promised to do. And so slashing is the underpinning of verifiability. So AVSs have that property that somebody running AVS software gets slashed if they do anything that the AVS said is a forbidden behavior. And then, as I've been saying, I repeat a lot of things in the presentation, but that helps. It takes me 5 times to remember something when I've heard it. So, on-chain and off-chain verifiable actions, we need to have both of them. I'll be talking later in a panel about zero knowledge. Zero knowledge is amazing. Zero knowledge can prove, as long as you're okay with the computation overhead, essentially every possible on-chain verifiable action. Zero knowledge can prove absolutely zero of off-chain verifiable actions. Off-chain verifiable actions can only be proven by humans and our shared belief. And so I find that a very positive statement because it tells me that, as we go forward in the world, humans will not get completely eliminated from technology. We do have a fundamental value that AI can't replace us. And the net takeaway of this entire section is that these autonomous verifiable services, these are the software as a service for Web3. And, it's a good, powerful statement to say that because autonomous verifiable services, EigenLayer itself is not a chain, and AVSs do not need a chain. They just need to bind themselves to ERC20 tokens as security for good, bad actions that are defined for that service. And those can be on-chain verifiable, where you're actually proving, like in Filecoin, that somebody no longer holds a piece of storage. Or they could be a promise that somebody made off-chain. You literally can have somebody create an Uber replacement service, and the one net new thing about it, everything else on it can be exactly the same as Uber, but the one new net thing is that they say the most of money they'll ever take from a driver is 10%. Uber takes actually up to 75% these days, which is kind of shocking. It's somewhere between 50 to 75 in most cases. And that's not something you can prove on chain, but if you actually promise that you're going to not take more than 10%, and then if you as a company put up a $2 billion stake that you'll lose if you ever do that, then you can actually make yourself a decentralized trust Uber, even though you have implemented absolutely zero of your technology using anything on blockchain other than having this proof and slashing condition. So it's a very powerful absolute statement. And feel free to talk with me afterwards because I really haven't gone in the tremendous depth because I want to hit AI as well. So for AI specifically, AI agents are like all the rage right now. I just want to level set us that an AI agent is a lot more than just an LLM model. If anything, the model itself is down in the bottom left kind of pinkish color box. Orchestration is how the LLM itself is kind of controlled to go through iterative steps. And then there's also tools which connect an agent to the outside world. And so when you put these 3 things together and you get, want it to be a verifiable agent, you have to make all 3 of these categories verifiable. So the orchestration in the model, they actually, they have a certain class. The tools have to be verifiable. The model and the orchestration, those are verifiable on chain. For performance reasons, you may want to verify them off chain as well. But in theory, you can make everything ZK provable, or have fraud proofs and have them verifiable on chain. And the tools, however, are a completely different story. So I'm going to show you in the next slide what I mean by them being verifiable off chain. So in this anatomy, the way that I like to kind of show the picture for it is that the orchestration and the model are like, our brain. So they sit in a completely separated spot from the rest of the world. It's, like if you think about our brain, it sits inside of our skull, a casing. It doesn't actually see the outside world. It doesn't feel anything. It's just pure computation. It's like in a very dark corner. The only reason why we feel like we're connected to the world is that we have these tools, which for us are, hands, eyes, ears, things that allow us to sense the world, and then muscles that allow us to interact with the world around us. And these tools for an AI, which are going to be it being able to put bounties in the world, have things perform for it, as well as to sense things from the outside world. Imagine if you were operating under the very sad situation where somebody could hijack what your hands are feeling, or somebody could hijack, how the muscles in your legs are operating. Your brain would actually be detached and not trustable at that point. So it's a very powerful statement to say that an AI agent, to be able to operate in the real world, needs to be like us. It needs to be able to trust its senses and trust the actions it can make. So the AVS ecosystem, I'm not going to go through these slides, but feel free, if you follow me on Twitter, they'll be posted over there, that there's a lot of components that actually are needed to make an agent fully verifiable, some of them on-chain and some of them off-chain. And it's a mission of EigenLayer that we want every single one of these boxes, every single one of these categories to be verifiable. Just giving you a feeling of like the momentum that we've had in the developer space. A little over a year ago, we put down these categories. We didn't expect them to all get filled up, but in 1 year's time, there were, I'm highlighting one protocol per category. In reality, we have multiple in each of them. All of them are being built, and, which was a really amazing outcome. We're very, very grateful for all of the people building new protocols that put their trust in us. And this was a nice thing we found out at the end of the year, that Electric Capital, that tracks these things, found that in the whole crypto space, EigenLayer was the fastest growing developer ecosystem. I can tell you it's not because we do great BD. It's actually very hard to do that. We're a very small team and everything else. The value proposition of building on EigenLayer is the fastest way to accelerate your innovation. Similar to like Amazon in the cloud, if you make it easier by abstracting away what people need to build, then they're going to want to choose a platform that gets them to the end result, which is delivering their value-add service faster. So new category map that I just like to show now is that for AI specifically, we kind of refactored it, and there's a couple of services that do not have people building the protocols in them yet. And so, there are some greenfield opportunities. In general, I think that AI and agents are going to be the biggest transformation we've had in computers since the transistor was created. And they're going to be bigger in a lot of ways than the Industrial Revolution as far as what technology can do now. So, super exciting thing. For AGI in general, I think one really positive statement is when you look at the two categories of the world, some people think that AI and AGI is going to be a utopia. Some people think that it's going to create disaster for the human race. And the reason is that if you look at AGI and AI, they are limitless intelligence, but they're limited by exactly the thing that Web3 and blockchains give you, which is verifiability. And so the verifiable AGI that you want, which is trustless, is the thing exactly that Web3 can bring. And so in the version of Utopia, you want AGIs to learn how to be symbiotic with humanity. If you happen to subscribe to the dystopia view, then you want to be able to limit the AI from getting out of the cage and causing all sorts of havoc. And for both of those cases, being verifiable and being constrained by crypto protocols allows us to prevent the dystopia and to achieve an AI utopia. Okay, so I have a couple slides in open tech and cloud. I think I'm going to skip them just because I'm a little bit behind on time. But overall, it's a positive message. You can come up and talk with me afterwards. Essentially, what it means is that with Web3, if you look at the place of where open source was, in Web2, unfortunately, open source ended up being utilized by cloud providers, and that took away a lot of the value from people in this room who build software themselves. And in Web3, the verifiable cloud The software runs on a whole bunch of decentralized physical infrastructure. A lot of it is going to run as AVSs on EigenLayer. And there's no platform at the very bottom that is taking the open source software and repackaging it and selling it out of its own platform instead of by the software developers. So there's a lot more money to be made by software developers. In the evolution of open, if you look at it, I think it's inevitable. We always go towards having more open technologies. Web3 is the open technology upgrade of Web2. So the centralized public clouds that we use right now, that the platform inside of like an AWS or Google, they have their own integrated software apps. That goes away and it becomes a bunch of crypto apps. Nobody owns Filecoin. Nobody owns, a Lagrange or a succinct prover market. These are completely permissionless, open APIs, open source software that's never going to look to eat the very people that are building the OS on it. And I don't know if a lot of people track this, but I find this very encouraging. If you look at the amount of revenue that is spent on software and hardware in technology, this is not a small number. And, this is not $5 trillion of stake. This is, passing $5 trillion of revenue per year. I mean, think about what the difference would be in crypto if we captured 10% of this. $500 billion of funding coming into crypto protocols, crypto DePIN. That is the future that I think we're going to be moving towards. So I'm very, very optimistic on crypto's future in the next 5 years. And then finally closing, just 2 quick slides. One, the takeaway from all of this is that Web3 is better for investors. It's going to be the best place to be investing money in startups. And it's better for building. As an open source developer, you don't actually have your software taken by public clouds and monetized outside of your benefit. And the data and identity that you need in order to build your network effects is available. All the data on a blockchain is there. You can just grab users. World is a great example of that. They were just talking. But all the protocols, Near and Ethereum, Solana and Bitcoin, all of this is the network effect that if you're competing against Facebook or Twitter or YouTube, you don't have access to that data. In Web3, you have it. So you can actually build a faster application growth. And it's better for outcomes. There's more ways to monetize, and there are many more ways to exit into public markets much faster. In the enterprise market, it can take 5-7 years for software to be public. And here in Web3, it can happen in 18 months, which is remarkable. Consumers win because they get superpowers. Privacy is by default. We have Zach from Aztec is going to talk with us. Your hard-worked data, you bring that with you. Your hard-earned reputation, that's yours, and you can bring it to every new application that you're on. That is not what you get in Web2 at all. And probably to me, one of the most important things is you can choose feed and recommendation engines that match to what you want out of technology, that are not matching to you basically being monetized through advertising, which has not been good for people at all. And the closing message for the entire talk here that I would say about Web3 is that it encourages there to be real competition permanently. And competition innovates and gives us a lot of new capabilities. Monopolies, which is where we are in Web2, stagnate. They no longer need to build new technologies. They need to increase profit. They need to increase people doom scrolling through apps and others. And that stagnation is the reason why I think so many people are disillusioned with tech right now. Web3, in my belief, is going to fix all of that. All right. Thank you very much.